This is the ocean desert, the fabled Sargasso Sea. This is the sea of legend, the sea of sargassum weed. The sea whose heaving surface is sometimes covered by the weed from horizon to horizon. The living weed, rooted nowhere, but living, somehow living, throughout the vast inhospitable expanse of the ocean desert. This is the mystery sea of legend, the sea ancient mariners said of becalmed ships drifting endlessly entangled in the weed, ships and men doomed to be carried relentlessly inward in a giant eddy. Inward to the graveyard of ships at the center of the Sargasso Sea. That is the legend, an old sailor's tale. Or is it? December 5th, 1945. A flight of U.S. Navy Avenger torpedo bombers takes off from a Florida air station. The planes are bound for the Sargasso Sea. This is a routine training flight. The crews have made it many times before. All radios are in good condition. 1 hour and 45 minutes later, the control tower is advised that not one of the 5 navigators knows where he is. The flight leader reports, still not certain, but believe we are about 225 miles northeast of base. Looks like... And the radio cuts off. That is all. An air and sea search begins immediately. A Martin Mariner flying boat with survival and rescue equipment heads for the presumed position of the planes. Again, that is all. The control tower cannot reach the Mariner. That plane, too, vanishes without a trace. Aircraft carriers launch search planes. Others take off from shore bases until 250 aircraft are crisscrossing that little piece of the Sargasso Sea. Surface ships join in, but no scrap of evidence is ever found. A Naval Board of Inquiry reports, we are not able to make even a good guess as to what happened. This modern legend of the Sargasso Sea is called the mystery of the Bermuda Triangle. What is out there in this ocean desert? The Navy is determined to find out. One thing certainly is weather. Unstable weather, affecting the whole North Atlantic and the continents that border on it. The Sargasso Sea is a birthplace of weather, good and bad. The ancient legends of giant eddies are true to a certain extent. The Navy studies these peculiar currents and the relationship between instability in the air above and the sea below. Sound propagation studies are vital for submarine and anti-submarine forces alike. And sound propagation varies tremendously with changes in salinity, in water temperature, even in fish population. The Sargasso Sea's peculiarities in these very factors make it a living laboratory. Study in the laboratory we call the Sargasso Sea is part of the worldwide program directed by the Oceanographer of the Navy. This research ship is making basic sound studies. The information gathered on each sea trip is analyzed for years in the laboratories ashore.
Hydrophone this time. 3K, 4K, and 5K. We're waiting for shot number 1, by the way. There she blows. Shot number 1.
A sound pattern made visual, to be compared with simultaneous records of salinity, temperature, and other controlling factors. Studies affecting undersea naval operations and long-range undersea communications as well. Much of our knowledge of the Sargasso Sea and other ocean areas is collected by research vessels of the Naval Oceanographic Office. Some of these vessels have been loaned to oceanographic institutions and universities so that scientists can work on both Navy-funded projects and their own independent studies. The men aboard these research ships study all aspects of the ocean desert: sound propagation characteristics, water temperature at all depths, chemical composition at different points, amount and type of life at each level. Aircraft of the Naval Oceanographic Office carry other scientists over the Sargasso Sea to cover larger areas. From all studies, from reports that date back as far as Columbus himself, oceanographers have developed a picture of the Sargasso Sea and the forces that shape it.
2810 fathom.
2810.
The first part of the puzzle is location. Where is the Sargasso Sea? We are there for the moment aboard the Navy's research vessel, Nord. Master of the ship is Captain Emerson H. Hiller of the Woods Hole Oceanographic Institution. He has carried many a scientist to these waters and back and forth across them.
I suppose one of the big problems of the Sargasso Sea is trying to define it. I don't think I've ever read a formal description of the boundaries, but generally speaking, we've always assumed it to be the area of the Atlantic Ocean, which is bounded on the west and the north by the Gulf Stream, which flows up our east coast, and on the south by the equatorial current, which and it stretches out into the Atlantic Ocean, probably to the mid-Atlantic ridge. When we leave on the ship from Woods Hole and sail south, as soon as we cross the Gulf Stream at about 38 north, we start to see the Sargasso weed and assume that we're in the Sargasso Sea, roughly between Bermuda and the Bahama Islands and the coast of the United States. That's where we usually see the greatest concentrations of the weed, and that's probably why they call it the Sargasso Sea.
At Woods Hole, Massachusetts, scientists of many disciplines study the data brought back by the research ships. Oceanographer and meteorologist Joseph Chase is concerned with the movement of air masses and their effect on the ocean, including the ocean desert of the Sargasso Sea.
The Sargasso Sea is a desert area in the middle of the ocean. It's part of a belt of dry area around the globe. Starting here with the Sargasso Sea, this belt is generally found at around 30 degrees north latitude. Here's the Sargasso. Here is the desert of Mexico and southwestern United States. Here is a corresponding dry area in the Pacific Ocean, 30 degrees again. Over here on the mainland, the Gobi Desert of China, the Great Indian Desert, the Arabian Desert, and the North African Sahara region, and back again to 30 degrees at the Sargasso. This area is dry generally because of descending air, and that comes about as follows. Here in the low latitudes of the northern hemisphere is where most of the heat reaches the surface. The air is caused to rise, being heated. Rising air cools and comes closer to its condensation level. This air, as it travels up here, finally finds a place to come down at about 30 degrees right around the globe. Since there is a great amount of evaporation taking place into this dry descending air, there is a lot of evaporation coming out of the ocean, water vapor coming out of the ocean, and the remaining salt results in a higher salinity for the middle of the Sargasso Sea, a desert at sea.
Atmospheric conditions above the Sargasso Sea are reflected quickly in the weather of the North Atlantic and the entire Atlantic seaboard. Those conditions are recorded continually at the Naval Weather Service Command in Washington. They will affect fleet operations, commercial aircraft flights, shipping and fisheries, almost every human activity in the Atlantic basin. Lieutenant Commander Edgar M. Chase, a Navy meteorologist, watches the shifting day-by-day patterns of the air masses over the Sargasso Sea.
This surface weather map shows the Bermuda High located over the Sargasso Sea. The Bermuda High is an area of clockwise wind circulation around a high-pressure center. Winds generally light, and the temperature range is generally small. The Bermuda High migrates seasonally, moving to the north in the summer and back to the south in the winter. It tends to force the weather patterns moving across the United States around the top of the high pressure center. When it moves, it can open the gate and allow for very stormy regimes in the Atlantic. These are time-lapse photographs of a hurricane put together by Dr. Fujita of the University of Chicago, showing a hurricane moving through the Sargasso Sea. As you can see, they give the appearance of a giant whirlpool. Some oceanographers believe that ocean currents in the Sargasso Sea, like currents in the air, create whirlpools that carry warm water down to the depths.
Dr. John C. Beckerly has ridden a Woods Hole research vessel through the eye of a Sargasso Sea hurricane, searching for the relationship between air currents and sea currents.
You just saw a remarkable motion picture of a hurricane over the Sargasso Sea. And these wind systems are important for the oceanographer to know since they drive the oceans. Within the sea there are eddies also. Here is a photograph we call the Smith-Benton eddy, taken from an airplane. It's about a mile across, showing spiral arms. This was near St. John's Island, which is very close to the Sargasso Sea. The vastness of the Sargasso Sea makes it very difficult to study the spatial and temporal variations that occur in it. This chart contains lines of constant depth for the same temperature, 20 degrees centigrade, and it reveals a pattern of circulation, or at least it appears to reveal a pattern of circulation in which there's a large central circulation. In the northern portion, we have a large meandering flow toward the east, and we think this is part of a large wave which tends to propagate toward the west with a very long wavelength, maybe the order of 240 miles. If this is so, and it is moving toward the west, well, you can use this fact to predict ocean currents.
The varying currents of the Sargasso Sea are under study, from the surface to the very bottom. These instruments are spaced along a line reaching 13,000 feet down. They'll measure and record the shifting seas day by day for months. Then the ship will return to retrieve the records and drop new probes. Floats at intervals will support the line and instruments, with a buoy marking the array at the surface. This current meter has been here long enough to attract the inquisitive fish of the ocean desert. And the fish attract the even more inquisitive marine biologists, scuba diving oceanographers. Marine life is part of the ocean desert phenomenon. In some parts of the ocean, schools of fish form layers almost impenetrable to sonar. Is that true here? What about jellyfish, like the Portuguese man-of-war? Do these and other species resonate to sonar and give false echoes? The poisonous tentacles of the Portuguese man-of-war act as rudders as the surfaced bodies sail before the wind, their only means of locomotion. In the Sargasso Sea, the tentacles normally grow on the right side of the body. Below the equator, where wind and currents are reversed, the tentacles are normally on the left. Among the tentacles are Nomeid fish, living out their lives as though attached to this one man-of-war. The sargassum weed itself throbs with life. To the oceanographer, the community of sea creatures in the Sargassum weed is a study unto itself. In this vegetation of the ocean desert, the young of many species take cover until they're old enough to brave the seas. Other communities live out their life cycles here, animals with strange names and stranger shapes. It was probably an ancestor of this crab that Christopher Columbus picked up from the weed on his first voyage to America. He reported in his journal that the crab and the weed convinced him he was not far from land. Actually, he was only midway across the Atlantic, and the bottom was 5 miles below his hulls. The Sargassum crab adopts the protective coloration of his environment. The filefish has skin like sandpaper. The Sargassum fish has evolved to live on the Sargassum weed. His forefins have been modified into jointed arms with which he pulls himself through the weed. However small the living organism, it faces the drama of survival. A tiny crab, its prey, a somewhat larger shrimp. The study of these little creatures moves hand in hand with physical oceanography. Dr. Richard Backus at Woods Hole has found biological changes from section to section of the Sargasso Sea, matching the variations found in thermal and salinity studies.
Following the discovery and study of the region of the thermal fronts in mid-Sargasso Sea by Boris and Hersey, Katz, Beckerle, and others, my colleagues and I decided to see if there were a change in the midwater fish fauna as one went across the region of the thermal fronts between southern and northern Sargasso Sea. We made a series of midwater trawls along the 70th meridian from the Antilles to the Gulf Stream. We located the thermal front, whose position changes, by making hourly bathythermograph observations. Aside from the fact that the catches in the southern Sargasso Sea are noticeably smaller than those to the north, there's no very conspicuous difference between south and north as the net's dumped. When one gets back to the laboratory, however, and sorts and identifies the fishes, a conspicuous difference is clear. The difference is symbolized by these two trays. This tray represents the midwater fish community of the southern Sargasso Sea. This tray represents the midwater fish community of the northern Sargasso Sea. In addition to the fact that one catches much less to the south, you can see that the fauna is more diverse to the north, that is, there are more species are caught to the north, and also the maximum size attained by species is greater to the north than it is to the south. All in all, this southern Sargasso Sea is the most impoverished place that we've ever fished in all the North Atlantic. The north-south difference is no doubt traceable to the difference in the temperature structure of the upper part of the water column in the southern and northern Sargasso Seas. To the south, the water column is stable at all times of the year. Consequently, there's no winter overturn as there is in the northern part of the Sargasso Sea. This winter overturn brings nutrient materials from down deep back up into the well-lit surface layers where plants can use these materials for their growth. This greater plant growth to the north explains all of the other biological differences between north and south.
Even though the Sargasso Sea is a desert of the ocean, there is still an abundance of microscopic life here, as there is in the deserts of the land. Oceanographers use plankton nets to collect the tiny organisms, both plant and animal, that swarm in the ocean water. The catch is examined to see which life forms are present and in what quantity. This helps oceanographers learn about the chemical structure of the water, the nutrients present in it, the current patterns, and characteristics of sound propagation. This marine biology affects the Navy. Other catches from the same plankton net are studied by oceanographers concerned with our food supplies. The Sargasso Sea yields larval forms of many game and food fishes. These fishes are studied at the Institute of Marine Sciences of the University of Miami. This is one of their prized catches, a record sailfish, only 1/6 of an inch long, probably the smallest ever caught. The tiny fish is observed through a microscope and sketched. This is part of a study of various types of billfish, proceeding here under the direction of Dr. Donald De Silva.
Scientists and anglers for many years have been very interested in the life history of the marlins, the swordfish, the sailfish, the spearfish. And here at the Institute of Marine Science, we've been interested in developing a study of the life history pattern. Now, the Sargasso Sea is extremely important to us because we find that this is an extremely important area for the spawning of these fish. This represents the distribution of larval, that is the baby billfish and marlin. And we find that the distribution of these larval stages represents very closely the pattern found by physical oceanographers in the study of the currents. This is a small feller about 4 millimeters. It's found in at the edge of the Gulf Stream where it flows into the Sargasso Sea. These are slightly larger ones. These are about 6-7 millimeters, and notice the development of the bill. The smaller ones don't have this. A little bit larger form, where you can see the sail first developing and the lengthening of the bill again. All these little fish hide in the sargasso weed and eat copepods and other shrimp-like organisms. And then finally, in these small larval forms, we have a sailfish with a very high dorsal fin. We don't know what they use the fin for, but they apparently use the bill to stun their prey. Now these are relatively rapidly growing forms. We know they grow from just this size to 5 feet long in 6 months and about 6 feet in a year. This vial contains a blue marlin, only a few days old. It's about 1/6 of an inch long. It seems incredible that this fish can grow in a matter of 5 and 10 years to a fish this size, which is about 400 pounds. We know that they go to over a ton, so that this fish here is only a baby.
The migration of the eel is another fascinating story of the Sargasso Sea. These maturing eels, captured in a backwater of the Potomac River, were born in the Sargasso Sea, as was every eel in every river and bay of the American Atlantic coast, and every eel of the European Atlantic coast as well. At least that's the theory of Danish oceanographer Dr. Johannes Schmidt. If that theory is true, these eels are preparing to return to the Sargasso Sea to spawn, and then to die. Specimens have been taken at each stage of the journey of the American eels by graduate student David Dean of the University of Miami.
This small larva is the young of Anguilla the eel and was found in the Sargasso Sea. This is the adult of the same eel. One of the problems still remaining in Schmidt's theory is that the adult has never been found in breeding condition in the Sargasso Sea or any place else in the ocean for that matter. If we trace the eel back to the Sargasso Sea through a series of sizes, we can see how it grows. We have the adult, which leaves fresh water and goes back and which lives in fresh water. We have the juvenile, which is found ascending the rivers in fresh water. And we have the elvers, which are found just outside of fresh water in brackish water, which have undergone metamorphosis. We have Leptocephalus larvae, the largest of which are found near shore. As we go back to smaller and smaller larvae, we find larvae that are found just on the edge of the Sargasso Sea. And we return back to the very small larvae which are found in the Sargasso Sea. The empty dish represents the egg, which has not been found in the Sargasso Sea as yet. This leaves us with two problems. neither the egg nor the spawning adult has been found in the Sargasso Sea, nor just about any place else in the ocean for that matter.
The search goes on. The search for all the facts of marine life and of marine phenomena in the Sargasso Sea. This is a Navy research vessel engaged in the Oceanographic project, a study of 1 single square mile of the Sargasso Sea. The same square mile every 3 months for 4 years, under the direction of the Naval Underwater Systems Center at New London, Connecticut. Also involved are scientists of the University of Rhode Island, the Smithsonian Institution, the Naval Oceanographic Office, and the Bureau of Commercial Fisheries. They are trying to analyze every aspect of that 1 square mile of water and of its seasonal and year-by-year changes. Fact after fact is poured into the Navy's computers in Washington. The information is at the disposal of any scientist working on problems of the sea, as well as those engaged in Oceanographic. The physical specimens are housed at the Smithsonian Institution, also in Washington. And these, like the computer data, are available to any accredited scientist. Young billfish, squid of many types, black anglerfish from the abyssal depths, flying fish, hatchetfish, the sargassum fish, camouflaging himself to match the all-protecting weed of the ocean desert, and the lanternfish, tiny creatures whose resonating swim bladders reflect sound beams and confuse sonar. The life forms of the Sargasso Sea, still one of the great regions of mystery and myth in man's world. The vast emptiness of the ocean desert is now marked here and there by the instruments of man, the probes of the Navy and of associated scientists trying to read the mysteries of one of the most unstable regions of Earth. A net captures the microscopic life of the waters. A hydrophone listens to the sounds of the sea creatures. A bathythermograph takes the temperature of the deep. A transducer probes with sonar, then listens for the slightest echo. And man himself descends when the occasion demands. Slowly, the Sargasso Sea is yielding new knowledge. Knowledge that will guide the Navy and all who use the sea to better understanding of the ocean environment. Knowledge that brings closer the day when man can fully utilize the resources of the seas.